Think about critical grid components like underground feeder lines, switches, and dead front transformers. There are an awful lot of them, but despite their importance, most are unmonitored or have only visual fault monitoring, which requires costly on-site inspections. Remote monitoring is difficult because these assets don't have a power source a monitor can draw from. A fault in any of these could cause outages that cost a lot of time and money to locate, diagnose, and repair, and failures in some could seriously damage your reliability scores. Blindness to these assets reduces reliability and leaves utilities and customers vulnerable. But how do you power a monitor without a power source? To date, utilities have relied on a couple of methods. Battery power is one. However, batteries require costly regular maintenance, and even then, they fail unexpectedly. You only know a battery-powered monitor isn't working when customers report an issue the monitor should have flagged. In terms of customer service and your SAIDI score, that's too late. Potential transformers are another power source for monitoring dead front assets. However, they are expensive and bulky. They're expensive even before installation costs and the cost of the necessary monitor. To date, these limitations have held back utility efficiency and smart grid efforts, but not anymore. What you're seeing is the installation of a new kind of monitoring system for dead front transformers and other assets. This system pairs the Transformer IQ monitor with a current transformer or CT power supply. This CT power supply draws power parasitically from insulated cables. Unlike battery-powered monitors, there's no maintenance, and you always know there's a monitoring solution at work. The system alerts if the cable from which it pulls power fails. Onboard supercapacitors ensure there's always power for last gasp messaging. It's also low cost and easy to install. As always, Transformer IQ units attach non-invasively with two powerful 75-pound magnets. You then attach the top oil temperature RTD to the tank wall. Of course, the RTD is attached to the appropriate input on Transformer IQ. Next, attach one Rogowski to each of the outgoing phases. Be sure to attach them in the right direction. The arrow must point in the direction of the load. The Rogowskis plug into the Transformer IQ unit. Lastly, we install the CT power supply and plug it into the unit's power plug. Within 15 minutes, you'll have installed a system that monitors faults, voltage, current, power factor, and temperature. You'll not only eliminate annual battery maintenance costs and improve your bottom line, you'll increase reliability. You'll no longer need to choose between leaving critical grid components unmonitored or spending fortunes on annual maintenance. Dead front asset monitoring just got practical and cost-effective.